Hey guys, sorry. I had a really long day and I forgot to do this. It's 11 o'clock now, as you can see on the screen. I'll upload it as soon as I can. All right, so multiplying radicals can only occur if they both radicals, oh geez, good typing there, have the same index. Okay, so if they don't have the same index, you can't multiply them together. That's what makes a radical a like term. So it's exactly the same, just like adding and subtracting. It's just like 6x times 3x is 6 times 3 and x times x. So here we've got -7 and 5 and 3 and 8. Now, usually we would just multiply these, but watch what happens. -35, because that is -7 times 5 equals -35, and then 3 times 8 gets me 24. So really I have -35 root 24. But we would never leave that, because that is 4 times 6. So out will come a 2, and I'll get -70 root 6. Now the reason I bring this up is because we could have simplified here, and we should simplify there. So when I get to here, I know that's 4 times 2, so out comes a 2. So really, I have root 2 times 6 root 2. Now, 6 root 2 times 2, which is 6 root 4, which is 12, because root 4 is 2. So it's really simple. You already know how to do it. It gets a little more complicated, but we'll talk about that in a minute. We'll just go through these really quickly. 12, you're going to want to simplify to 4 and 3. Bring out a 2. So you're going to have -8 root 6 times 12 root 3, which is -96 root 18. Now, of course, 18 is 9 times 2, so out comes a 3, and I get negative 96 times 3 is 180, and 18, oh, sorry, 270, and no, God, brain work, 288 root 2. Root 3 times root 3, of course, we know root 3 times root 3 equals root 9, or the shortcut, anytime you square a square, you get the radicand, so that's 3 times the root of 9, which is 3 times 3, which is 9. Now, when we get to something like this, it's just distribution. But again, you should simplify that 8 first, but rewrite, and then you really can't do it wrong. That's 4 times 2, so out comes a 2. 10 root 2, 3 root 2, plus 2 root 3, minus root 5. 30 root 4, haha, we know what to do with that, plus 20 root 6, minus 10 root 10. That's 30 times 2, which is 60, plus 20 root 6, plus 10 root 10, not plus, minus. Now, nothing changes when it's cubed, except you simplify. Now here's a good example of why we simplify. 16 times 54 is a gigantic number. I don't want a prime factor. If my calculator would open, I don't want a prime factor 864. So I come to here and I know that that's 8 times 2. And I know that that's 27 times 2. 8's cube root is 2, cube root 2. 27's cube root is 3, cube root 2. So that's 6, cube root 4. Now, a bunch of you are going to say, but I thought when those multiplied together that it canceled. No, because they are cubes. You would need to cube them to get rid of the cube. 28, 4 times 7, 9 times 7, 10 root 7 times 9 root 7, 90 root 49, which is 90 times 7, which is 630. And here. Notice, please, that this is just a binomial. So it's FOIL, but I'm going to simplify. 4 times 2, so that's 2, 4 root 2, plus 3 root 7, times 2 root 3, minus 3 root 2. And then we just FOIL. First one right there. 8 root 6. Second one, minus 12 root 4. I know what root 4 is, but I'm just writing it out so I don't screw it up. Plus 6 root 21, minus 9 root 14. Simplify everywhere you can. 8 root 6 plus 12 times 2 is negative 24 plus 6 root 21 minus 9 root 14. And that's it for multiplying. Dividing is similar to multiplying. We divide coefficients and we divide radicands. So here I have root 18 over root 3, which is root 6, because 18 divided by 3 equals 6. Now here, there's probably supposed to be an x there. I don't know why there isn't, but let's, assume there is. So this is 15 over 3 and root 15 over root 3 and root x cubed over x and root y squared over root y. And then we just do all of them. 15 divided by 3 is 5. Root 5 x squared y. We just follow the regular rules. Okay? I just got to pause it for a sec. Sorry, guys. Now, the problem with these is, I'll leave this up here. This divided perfectly. However, if a radical doesn't divide, then we can't leave a radical in the denominator. We eliminate them by multiplying by the conjugate. And the conjugate is simply this. If I have root A plus root B, I multiply that by root A minus root B. That's the conjugate. And then what do I get? Well, root A times root A is A minus root AB plus root AB minus B. And notice, plus AB minus AB fall out, leaving me with A minus B. And that's what we're shooting for. And this process we'll talk about in a second. First, let's talk about this. The conjugate of this radical. Remember, all we change is that sign. So it's root 17 plus 3 root 14. This is root 34 plus, not plus, minus 4 root 2. And this is just root 5. Because root 5 times root 5 equals 5, which will eliminate that radical. Okay? This is called rationalizing the denominator. And it's called that because we are making irrational roots rational. So let's show you how this is done. If I'm going to rationalize the denominator, remember, rationalizing the denominator means I take the denominator and I multiply it by the radical. Now, I can multiply it by 3 root 7, but I'm just trying to eliminate the radical. So I'm also allowed to just multiply it by root 7. But here's the thing, you guys know how fractions work. If I multiply the bottom, I gotta multiply the top by root 7. So I get 2 root 42 over 3 times 7, which is 2 root 42 over 21. This one, now, this one you see I can divide here, right? So I get 7 over 14 equals 1/2. So what I really have here is root 5, because there's the 1, over 2 root 6. There's the 2. This is ugly, so I got to multiply by root 6 over root 6 to get me root 30 over 2 times 6, because root 6 times root 6 is 6, which is root 30 over 12. And root 30 doesn't simplify. So that's where we stop. Same thing here. I got to get rid of the radical. But these are big numbers, so I'm going to simplify, because that is 25 times 2. So out comes a 5. 30 root 2 over, that's 9 times 2. So out comes a 3, which is 15 root 2. 30 divided by 15 equals 2. Root 2 divided by 2 cancels, and I'm left with 2. Same thing here. 60 is 4 times 15. 27 is 9 times 3. So I get 6 root 15 over 6 root 3. 6 divided by 6 cancels. Root 15 divided by 3 is root 5. Now here it's starting to get a little complicated. I'm not allowed that radical on the bottom, so I got to multiply by root 3. I got to multiply the top by root 3. But just like the last lesson, all we got to do is distribute. So I get 6 root 6 minus 3 over 3. Now, you guys know how fractions work. I do this one first, and that gets me 2 root 6, and then I do this one second, minus 1. Over here, same thing. I'm going to multiply everything by root 2 to get rid of this radical. So I'm going to get 3 root 24 minus 4 root 12, sorry, not 12, 4 root 6 over 2 times 2. Then I'm going to simplify. 6, this is 4 times 6, so out comes a 2. So it's 6 root 6 minus 4 root 6 over 4. Well, you can see you can do this subtraction right here to get 2 root 6 over 4. And you can see that the 2 and the 4 cancel to get root 6 over 2. And then I got just 2 more to do. Now, this one, I got to get rid of these radicals, so I got to multiply by root 15 plus root 10. Because remember, I want the middle term to drop out. Same thing up top. So that's going to get me root 7 times 15 is root 105 plus root 70 over 15 minus 10. Because we know what's going to happen there. So that gets me, we know this doesn't simplify, and we know this doesn't simplify because it's 7 times 10, which is 2 times 5 times 7. So what I have is root 105 plus root 70 over 5. And I'm done. And finally this guy, I got to multiply him by root 3 minus root 2, because we got to remember I got to use the conjugate, so the middle term drops out. So that's 3 root 6 plus I lie minus root 6 over 2 times 3 minus 2, which equals 2 root 6 over 6 minus 2 is 4. Do your canceling. Root 6 over 2. And that is it.